I will show you this comment later regarding this minimal. If we have some any complex profile, there we can get like minimal fillets. It's just simple command. Just to select this fillet and give the radius and select the corner, select sharp edges. Okay, and coming to chamfer, generally we are giving chamfer in sharp corners and to strengthen the material also. Suppose so actually this is a simple L block, but if you see this block, actually this don't have any strength in this corner support. So in such cases, we can add chamfers. So we can use like this also chamfer, and sometimes we are giving for the corners also to give some good like aesthetic shape to the part. This is about chamfer, and here actually we have some in chamfer definition window. We have a mode like length into angle, length into length, caudal length, height and angle, fold curve and angle, fold curve and length. So majorly in our industry we are using the length into angle, length into length. This I will show you here. Actually this is here 50 into 45 degrees. So in both sides it will take like 50 mm, 50 mm. If I change this one, actually I want some specific length here. Here I will give 25 and one side will be 50. So from this face to this face, it is take 25 and this direction, it takes 50. If you want to like reverse the direction means here we have the option called reverse. So if you check this one, automatically it will click. Okay. Generally, chamfer means we are like calling with 45-degree angle only. In drawing also we are giving chamfer if the dimension or a chamfer angle is 45 degree. If other than 45 degree, we are giving some like machining symbols and also machining dimensions. So can anyone tell that why we are using draft angles in like mechanical part or in a design? Can anyone tell? Okay, this is a draft definition, and here it is asking faces to draft. Which are the faces you want to draft? I want to draft the all surrounding faces like these four faces, and it is asking for pulling direction. So we have to give pulling direction with respect to this face, and I am giving 10 degree here. Yes. So actually for draft, we need we need to select the faces to draft and the neutral element. The neutral element in the sense it shouldn't change. Like we are not changing anything in the element. So just first we are taking these two faces and the neutral element we can select here. So automatically it asks for angle. How much angle you want to draft? Like 5 or 10. Okay. So automatically this part will going to change with respect to the given draft angle. And generally draft angle we are using in like press tool design or on injection molding design. Why? Because means one after creating a part inside that core, that part has to exit from the core. So if you give draft angle, then only that part will eject from the core. Okay. And coming to this one, edge fillet. So now I'm giving edge fillet here. Okay. Next, coming to the shell command. Actually, the shell command we are using to get a uniform thickness throughout the part. So if I select this face, just I'm giving how much thickness I want. Just I want 5 mm. So throughout the part it will take 5 mm thickness. Okay. The shell command is used to get the uniform thickness throughout the.
Excuse me, Guru sir, Guru Swami
Yes,
sir.
tell me, sir.
Hello.
Yes, sir. Tell me, sir.
ಸ್ವಲ್ಪ ವಾಲ್ಯೂಮ್ ಸರ್, ಜಸ್ಟ್ ಇನ್ಕ್ರೀಸ್ ದ ವಾಲ್ಯೂಮ್ ಸರ್, ಲಿಟಲ್ ಬಿಟ್.
A little bit. Okay, sir. Okay.
ಎಸ್ ಸರ್.
Now the shell command is clear, right? Now it is audible to everyone, right?
ಎಸ್ ಎಸ್ ಸರ್, ಎಸ್ ಸರ್. Now it's okay.
Yeah, yeah. Okay, sir. Okay. And then after shell command, here we have thickness. So in this, it is just add a thickness to the fail in which direction you want. So now actually after shell command, I have everywhere 5 mm thickness, uniform thickness. So from this one, I can add a thickness to any one of phases. So now I want this one for some 5 mm extra. So this is like the non-parametric feature. This one, these dresser features all are non-parametric because it is not linked with any sketches. Okay, and after this one, like if you want reduce the thickness, you can just give the like minus values. So automatically this value will going to show you 4 mm here. And this is clear, right? Up to dress up features, up to thickness.
The report was not joined. Please.
Yes. Yes, if you want any threaded options or a threader tab, we should have a circular part here. And generally for all fasteners, we have entry chamfer here,
Please join me.
regarding 1 mm or 0.5 mm.
Please. It is new link for first session.
Coming to this command, thread and tab. So it needs circular faces. We just selecting this face, and it asking for limiting face. We're selecting bottom face. So it
Mhm.
asking like
Okay.
which type of thread we want, like metric thread. So I'm giving M8 and thread depth will be around 20. So it is only reflect in drawing. Just I will
First session.
check this drawing.
Your partial was not joined.
You see,
It is joined by new link for today's frustration.
in 3D, it now not showing any thread dimension here, like it not highlighting any threaded option. But in 3 we have, and while we are generating drawing, here it will reflect.
So good morning, sir. Sorry for the interruptions. Can I ask some clarification, sir?
Yes, sir. Tell me, sir.
Sir, means if I want to see the thread in the outside of the nut, can we able to do that, sir?
Yeah, we can do that, but this option will won't work that time.
Oh, okay,
Actually,
sir.
we are
Okay, sir.
here. We are doing the thread and tap, right?
Yes, sir.
If we want to represent in the 3D means, we have to use like spiral command, and with that we are using like this one rip command.
Okay, sir. Okay, sir.
Uh,
Thank you, sir.
yeah, thank you. So if you check here, so automatically it will show the depth of the hole, like sorry, depth of the thread. So M8 and 20. But in 3D, we're not able to see that whether it is threaded or not. But in 2D, it will reflect. Okay. And coming to this option, remove phase option. Okay. Just we are removing the faces of the model. Just if I want to remove this one, I can remove here. Okay. And this is when where we are using means in some reverse engineering work, like we have one solid dump model. In that we have to create like parametric model. In such cases, we are using this command,
Basics.
remove phases. Is it audible, right? So this is about dresser features. Is it clear to everyone? Dresser features? Is it clear, right?
Yes, sir.
Okay. So after that, we have a transformation feature. Just I will show you.
Considering the different links. Already shared in the WhatsApp group, and this is the basics of conception of the geometry.
Just I shared one part in the group. Just we'll start with this one, with using this dresser feature. I'm taking these references here. This is axis, sir. ಹಲೋ ಸರ್ ಹೇಳಿ. ಹೌದಾ? ಹಾಂ ಸರ್ ನೋಡ್ತೀನಿ. ಲೌಡ್ ಸ್ಪೀಕರ್ ಇಟ್ಬಿಟ್ಟ ಮಾತಾ? ಓಕೆ ಸರ್.
Sorry for the interruption. Guru Swami sir.
Yes sir, tell me sir.
Sir, a little bit actually increase the volume, sir.
Yeah, okay sir.
Volume is very, very low. Guru Swami sir. Hello. Hello.
ಹಲೋ ಎವ್ರಿ ಒನ್. ಸರ್ ಇವಾಗ ಮಾತಾಡಿ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ನೋಡಿ?
Sir, you are audible, sir. Now you are audible, sir. When you are giving the
Guru sir, your voice is not audible. Sir, voice not audible, sir. Guru sir.
Sir, Guru sir, your voice is not audible, sir.
1 minute, sir. I will call to him.
Guru sir, can you click the three dots for the setting? I think he is not able to. Three dots in the lower section. Three dots.
ಈಗ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
Right.
ಸರ್ ಈಗ
Fine.
ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
And now it's fine. Now you are audible.
Now it's fine, right?
Now it's fine, sir. Now it's fine, sir.
Okay, sir. Okay.
Sir, voice is not coming, sir. Guru sir.
Is it okay, sir, now? Sir, is it okay?
Yes, sir.
now
Yes,
it's
sir. You right. We are able to. Actually, Guru sir is not speaking right now.
Yeah. Guru sir, you just loudspeaker.
Yeah.
Just open the loudspeaker and do it, sir.
Yes, sir. Just I am creating this drawing, this model.
Okay, done. Thank you.
Okay. And you just check with that on parallel, you can do that one, do that part. Okay.
दूसरा स्पिनर एक और लाओ यार, घूम रहा है ये। काट दो यार, एक स्पिनर और दे दो यार, खराब हो गया। कटर का वो कटर का कटर इसको पकड़ यार, एक है उसको पकड़, नीचे वाले को पकड़। लो
Actually, this model will take some time. Okay, so further we will complete this commands and then later we will start this part. Is it fine, sir? If we start doing this one, we are not able to complete the commands. are coming to features, I'm making a hole here. If I put next, it will through the hole. Just I'm defining the hole here. So I want to make a pattern here. So this is called pattern command. And here we can get a like circular pattern and also rectangular pattern and also user pattern. Actually, I want to pattern this hole here. I want some more holes here in this space, and I don't want to make it every hole like individual command, and also I don't want to waste my time with sketching the hole. So if I know the like instances and the distance between the holes, easily I can I can do by using this pattern. So if you're coming to pattern here, rectangular pattern, okay, and this is asking here this object pattern. In this object pattern, you just click on this one and select this whole feature, okay, and then it asking like in which direction you want. So it is asking about reference element. So here I'm selecting this face, okay, and it asking the instances how much you want. Here in first direction it's showing like 2 in 20, so I want 10, okay, and spacing about 20, so it is behind this part. I'm making like 5, and in second direction if I want, just select the second direction, and here you can just make the same 5, and how much spacing you want. Sorry, here it 1 or 2 it will come. Three here. Okay. With the same distance of 20. So automatically this code will come here. And it gives some error like tangential to the end. So we can make it. If you reduce this value, so it will come in the proper position. Before that, it is tangential to this face. So that's why it shows some error while we are doing. So this is very tangential to this corner. So while just observe this one. So you see, okay, it shows error like this. Tangent configuration. Okay, so to avoid this one, I'm reducing this distance. Okay. So this is a pattern, rectangular pattern. In this rectangular pattern, we have different options here. First one is default instances and spacing. Here we need to give how many instances we want and how much space we want in between the holes. Feature. So on coming to next point, here we have instances and length. We don't know the exact distance which come between the two holes, but we have total length, and we know that how much instances we want. In such cases, so here I'm selecting instances and length. Okay, so I'm giving instances like 4, and length will be 60. And I'm clicking this, like selecting the reference element. You see, in the 60 length, 4 instances will come in this direction, in this distances. So you see 20, 20 will come. Is it clear? This instances and spacing and instances and length is clear, right? Sir, is it audible now?
Yes, audible, sir. Audible.
Yeah, these comments are clear, right? Rectangular pattern.
Yes, sir, you are audible, sir. You can continue, sir.
Okay. And in same rectangular pattern, we have spacing and length. We don't know the instances, but we have we know that what is the spacing between the two holes and the total length. In such cases, you see spacing will be 20, so I make it 50, and I will give length around 75. And I'm selecting this object hole, and reference element will be this space. Okay. So in spacing of 15, over length of 75, you see this instances automatically will update. Clear, right? And coming to next comment, instances and unequal spacing. What we did, these three comments are like it will give equal spaces in between the feature like hole or anything. So now we are going to check about this unequal spacing. So here individually you can change the values here. So here I want 20. And again here I want 20. If you just check this one, from here to here it is 15, and from here to here this is 20. Here to here also this is 20. This is like unequal pattern, instances and unequal spacing. Okay. And so here I am leaving the blind hole. So here if you want to reverse the direction, you can just select this reverse. And if you don't want any instances in second direction, you can just click it one here. And actually for this hole, I gave like this, like bottom V bottom I want, depth will be 25. So here it's showing like this, because here due to less material it came through hole. Okay. And here we have some material below this hole. So here also
it came like flat hole. So if you select, while giving such cases, if you check this keep specification on, okay, automatically this whole features or specifications like V bottom will apply to these holes. Now if you check this face, you see now we have a V bottom here. Okay. Is it clear, right? Pattern with keep specification. So is it audible, right?
Yes, sir.
Yes, sir. You are audible, sir. You are audible, sir. Audible.
Yes, sir.
Yes, so now this comment is clear, right, sir? Pattern
Sure,
and
sir.
with
It's
specification.
visible, sir. It's visible.
Keep specification is clear,
Yeah,
right,
sir.
sir?
It's clear, sir. It's clear.
Yeah, okay.
Sir, how we have shifted the plane to check that?
This one, volumetric. This one you were asking, right? Dynamic sectioning.
Yes, sir. Yes, sir.
Yeah, here in pod modeling it is there. This is just an dynamic sectioning. If you just select this one,
Okay, sir.
and select any phases in the which direction you want to see the cut section.
Okay, thank you, sir.
So, and with respect to this arrow, you can just move on this one.
Okay.
Okay. Then you can able to see the cut section inside the part.
Okay. Okay. Thank you, sir.
Okay. Yeah. Thank you. So next coming to circular pattern. And for circular pattern, we should have one axis. Okay, that should be the holes will come in the circular way. So here we need to specify these things: instances and angular spacing, how much degree you want between the holes, and here also instances and total angle. Here angular spacing and total angle, and this is complete crown. And here also we have like instances and unequal angular spacing. So just I will instead of making all, I will create some part here. Now I have this feature, so I want to create circular pattern here. Just select this circular pattern, and in the current object pattern, in the object you can just select this feature and select the reference element here. So you see here, if I increase the angle, increase the instances, so it will come like this. So this is like instances and angular spacing, you know, then we can use this command, instances and angular spacing. And in second cases, we know the instances and the total angle, but we don't know the space between the instances. In such cases, just I want some 10 instances in the 60 degree, suppose. See, the 10 instances will come within the 60 degree. Okay. And the third command is angular spacing and total angle. In this case, actually we don't know the instances, but we know the angle space between the feature and also the total angle. If I select this one, I will give the angle is 10 degree and the total angle is around 220 degree. Take this one, you see how many instances it is showing here? It is showing like 23 instances. So it will calculate and it will give the result. If we input angular spacing and the total angle. So if you want in a reverse direction, you can just select this reverse. So it will take the opposite angle. And in other command, this is like complete crown. So it will calculate automatically like with 360 degree angle, complete crown in the sense it consider as a complete 360 degree angle. So it is asking about how much instances you want in this. So I am just giving 6. You see, the angular spacing is automatically calculated 60 degree. Okay, and in same way like a rectangular pattern, here we have instances and unequal spacing. If you select this one, you need to edit the angle, how much you want between the pattern. Here I want 80 degree. Okay, and here I want 20 degree. See, this is all about the rectangular pattern. So these all comments are clear, right? Regarding circular pattern. So then just we will move towards this one, like user pattern. User pattern actually it needs one defined sketch and the one feature. So I will show you how it will work here. So now we used almost like a regular path. So now, but in user pattern, we can use wherever we want. For this one, you need one sketch. In that sketch, you need to define the points definition, like where you want the holes like that. Just I will take this point.
ಇದು ಕ್ವಶನ್ ಬೇಕಾದ್ರೆ ಎಲ್ಲರೂ ಇವತ್ತು ಇರ್ಬಿಟ್ಟಾಗ ನಾಳೆ ಕೊಡ್ತೇನೆ share functions the function which describes the behavior of the elements is known as shape function. Under derived from the displacement. There are two different types of shape function.
One is this Hermit shape function. Shape function for higher order element, shape functions for different types of elements.
Actually, I have one sketch here,
Two ways.
and I have one feature
To
here.
derive the shape functions can be derived in two.
Okay, but in circular pattern, if I select this hole, so if I select circular pattern, this currents are at 4 and this phase, so it will come in one single layer, like in one PCD. Okay, but if you go through this one user pattern, okay, just select this user pattern command, and then the object, you can just select the whole here, and then select the sketch. Okay, user pattern, and I'm selecting the sketch. Here it asking for positions. For positions, you need to select the sketch. So if you see this one, it is like an irregular distances between the holes. These two patterns will give the in the linear way, and the circular pattern gives in like one PCD circle only, it will create the holes, and this user pattern will create like how sketch you develop na, in that way it will create the pattern. So this pattern feature is completed. So is it clear, right? Regarding all pattern features.
Yes, sir.
Yeah.
Clear, sir.
And here we have a transformations. In that we have translation, rotation, symmetry, and axis to axis. This is same like an mirror command we used in Sketch. But here we need one plane to define the mirror, mirror axis. So just I'm taking one plane. So it will be like here I'm changing. I want mirror this pad with respect to this plane. So here we have option called mirror. Just I'm selecting this part, okay, and it asking for reference plane. Just I'm selecting this one. So automatically this whole pattern or a body will mirror to the opposite section. If you want to mirror any feature, you should use this mirror option here. And if I want to move or rotate, here it is translation. Just select. It is asking for, do you really want to keep the transformation specifically? Do you want to move your geometry using compass or 3D constraints? You give it yes. And direction. This direction, I want to move this one like 50. So it will move below this axis. So this is about translation. So, and I want to rotate this part. So here we have a command called rotation. Just I'm selecting this part, selecting this axis. In which axis we want to rotate? You can just select that axis, okay, and give the angle, how much you want. Suppose I want some 30 degree. With respect to this axis, Z axis, okay, it rotated 30 degree. This is about transformation commands. Transformation and mirror. And here we have one more command called symmetry. So difference between the symmetry and mirror is, symmetry it will reflect and move the complete part, and mirror command will mirror the part and keep the original one. You see, there is a clear right about symmetry and mirror commands. There is no confusion with that, right? Sir, is it audible, right?
Yes, sir.
Yes, sir, it's audible. It's audible.
And these comments are clear, right? Symmetry and the mirror. The difference between the symmetry and the mirror.
Yes, sir, everything is audible and clear, sir.
Yeah, thank you, sir. Thank you. And this is we call like the scale. Here we have scaling and affinity. If I select this, if I want to increase the scale here, just I'm taking this one, scaling, and it is asking, this ratio is nothing but an scale, how much you want, like 1:2 you want, or 2:1 you want, okay? So I want twice the part, so I'm giving 2 here. So you see this phase will take it 2. Before, now this thickness is 50 mm. After scaling, you see 100 mm, because scaling ratio I gave it as 2. If I make it 0.5, it will come like 25 mm here. In which direction you want, you can just move that one using scale definition. And here one more called affinity. Actually, the difference between these two commands are, in scale command, we can increase or decrease the scale in one phase or something. In like one reference phase or this phase, or either this phase, or either this phase. Okay. But in affinity command, we can able to give the different scales in one command. So it is asking about the ratios. In x direction, I want 1. So this is called 1. So if I give 1.5, suppose. Okay. And in y direction, in this direction, I want 0.5. Okay. And in z direction, this direction, I want 0.25. So in all three directions, we can give the scale, since ratios, by using this affinity definitions. Point 5 here, and here I am giving 1. Okay. So this is all about this transformation features. So we covered all drop to fillet, chamfer, shell. So all commands were completed, and coming to annotation and few more things we have here. This is called the split command, and this is thick surface, and this is closed surface, and this is sieve surface. So generally we are using these three commands frequently, like this split, thick surface, and closed surface. So coming to split command, actually it need one solid body and one surface or a plane to cut that element. So actually I want to split this plate with respect to this plane. So in such cases, I'm just taking this plate and I select this body and I'm selecting this plane. So automatically it will cut with respect to the plane. Here if you want to reverse the direction, double click on the split, you can just click on this arrow. So it will show which direction you want to keep the material. So I want to keep material this direction, so my arrow is showing like this and I'm pressing OK. So this is about split command.
Sir, sorry to interrupt you, sir. I just want to ask in split command, the reference will be always a plane, or it can be a curve, or
It can be a surface also, sir.
okay, okay.
Surfaces. Just I will show you. So not only plane, we can cut the, like we can split the faces by using the surfaces also. Just select the split command, select the body and select this curve. So if you hide this one, you see.
Thank you, sir.
Split it with respect to that. Like where we are using means actually in assembly line fixtures we are using these commands like car panel milers or ANSYS we call it.
Okay, sir.
Okay, thank you. Then come into thick surface. So actually I have a surface here like this and I want to give thickness for that one. Select thick surface and select this one. Like how much you want you can give the thickness. So this is about thick surface command. So it will give the thickness to the any uniform surfaces. And coming to this closed surface, just I will show you one thing here. And in CATIA, the default hide and show will be using space button, space bar in the keyboard. Okay, if you want to show or hide, you can use space. So you see, if we using this one surface here, I have only surface here, but the difference between the thick surface and this one is different. If I use thick surface, it takes only the thickness. So the thick surface will give only thickness to the surface, but this closed surface you completely close the surface with respect to that like surfaces. You see, this is the surface. If I use this closed surface, automatically it will create complete solid body here. So these are in like product developments. Majorly we are using these commands like thick surface and closed surfaces because the all product development will be like in few product developments they done with generative shape design. So to get in thickness, they are using this command, thick surfaces. So it will come only if everything will be smooth like the tangential and fillets. Everything will be smooth only, then only this command will work while we are working in product development.
Hello.
Yes, sir, tell me.
Sir, will this closed surface command will create a solid surface or it will be hollow from inside?
Sir, I'm not clear with your voice. Can you please talk
Like,
loud?
hello.
some sound will be coming like.
Sir, Priyank sir want to ask that for the closed surface, if we are going to use this command, is that surface will be solid from inside, or it will be a hollow from inside?
Hollow,
Yes,
sir.
sir.
It is a
Hollow.
hollow form.
Okay, okay, sir. Thank you.
Yeah. And we are done with all these like the sketch-based features and dresser features, transformation features, patterns, and scales. And also the surface-based features. And coming to these annotations, so it will reflect in the 3D. So I want to give some information about this part in 3D itself. Means you can use this annotation command, text with leader. Just select this command and select any of the corner. So you can give the information about the part. You see, you can give the information in 3D by using these annotations. And this is about annotations. This is text with leader. Generally, we are using this command, text with leader. So without arrow, also you can give. Later also you can add a leader to the text. Here you can add leader. You can just select any phases. So now we will take a tea break. After 10 minutes, we will continue the session.
Okay, sir.
Yeah, thank you, sir.
Okay, sir. Okay, sir. Participants, you can take the tea break for 10 minutes, and after that, you please join the session. Thank you.
Yeah, thank you, sir. Thank you. Sir, shall we start?
Yes, sir.
Yeah, okay, sir. So we are done with all these dresser features and the sketch-based features and also annotation. Next, coming to this one. This is dynamic sectioning. If you want to see any cross like cut section in the 3D maze, we can use this command dynamic sectioning. You can just select the phase or a plane and you just keep move on. So it will show you the inside section of the part. And then this measure command, here you can measure the distances from face to face array, point to point. And also it gives you the angle. And this is about measure item. Like it will measure the line or curves. It will give the length for the curves radius and also the lines. And here we have inertia. Actually, for simulation, we should give this inertia values. So for that one, we should apply the material here and command is here. Okay, this is we call apply material. If you select this one and select the body, and you can apply the which material you want, whether it is aluminum or a steel or a brass. Okay. Okay. Just I'm applying material here. So if I check with moment of inertia, it will give the weight here. So if you want to change density, you can change here. So generally for steel, up to we can use 7890. So here it will show like mass will be 1.5 kg. And also if you want to create the CG for this one, here create geometry, okay, and this will be like associative and it asks for non-associative. Associative means that point will associate with this part. Non-associative means that point is not related to this one. You can delete the part also, that point will reflect there. Coming to non-associative geometry and center of the gravity, okay, and here it will create the point called CG, in the sense center of gravity. Okay, this is one useful command when we are giving input to the simulation people. That is it clear?
Yes, sir. Clear, sir.
Yeah. So this is about apply material. Okay. So actually I applied the material, but here color is not reflecting. Okay. And for that one, actually we have this toolbar here, view. In this, I already explained this one. This is for fit view, and this is for pan, like a move. I'm selecting here, and I'm moving here. Generally, we are not using this command much because mouse itself we have, and this will be the zoom, zoom in, zoom out, and here we have this create multi-view command. If you select this one, it will create the part isometric, top, front, as well as the side views. This create multi-view command. So if you just unselect this one, again it will come to the normal position. Okay, and coming to here, this one view, here we have like isometric and front view and back view, left, right, top, and bottom views. So if I select isometric view, it will come to default isometric orientation of the part, and this is like front view. Okay, and this is top and top view. Like this it will come, but actually we applied a material here, but still it is not reflecting on the part. So for that one, here we have a command like shading edge, shading with edges, shading with edges, smooth edges, without smooth edges, and here we have a shading with material. If we select this one, automatically the applied material will be reflect on the display. So suppose if I change this material to other color, suppose I am putting gold, so automatically the color will change. And if you put any other color like stone or wood, like a beach color, you see that color will reflect here. If you select only the shading with material, default it will be like this, shade with edges. Okay, and if you select this one, first one, shading, so it will just hide the edges. You see, now we are not able to see any edges of the part. If you select this one, shading with edges, then only it will reflect the edges in the display. So this is very useful commands. And if you want to see the wireframes, so you can just select here wireframe. So it will show the wireframe of the part. Okay. So this is about these different types of shading materials. View modes. Sir, is it clear? V mode comments are clear?
Sir, yes, sir.
Okay, then next. So these are the major commands we are using in part modeling. Sir, any doubts you have?
No doubt, sir. No doubt, sir.
No doubts, right?
Yes.
Okay. So actually we have two more commands here. Sweep visible space, hide and show. Suppose if I hide this part here, okay, we are not able to see this one. So it's a hide in the backspace. Like in that time, you can just sweep visible space means it will just tap the window from this current display to the hidden display. You see, this will be the background display. So you can just make it sweep visible space means it will show here. So then here you can again hide and show this one, and you can again show this one means it will come to working mode. And coming to this one, the stiffener. So stiffener means it's in some of the tools we call it like rib. It is just like an supporting member to the part. So currently, this part is weakened here, and we want to add some support. So by using this command, stiffener, we can give support like that. For that one, we want sketch. I'm drawing one line here. So I want support like this, and here we have a command called stiffener, and I will select this one, this sketch. So it will ask for thickness. Whether if yesterday I showed you about this neutral fiber command. So if you take neutral fiber, the thickness will be uniformly distributed in both sides. So now I want 5 mm one side and 3 mm one side from the sketch. Okay. So if I want uniform thickness, so for the 5 mm, it will take 2.5 both the sides. This is about stiffener. And we are done with part modeling. And I will show few few options here. So if you want to create any shortcuts, just click on right click here. Here go to customize, and here you have comments, and you can just here select all comments, and here you can just check for which comment you want shortcut. Hide and show. In CATIA default it came for space, and for other comments like I want pad. So if I put any shortcut, automatically you can use it here. Just in accelerator, you can just create the shortcut and then just close. If I just select Alt P, see automatically pad will come. Okay, in such a way that you can create a shortcuts to many commands like fit view and properties. Generally, we are using properties and many more. Like frequently, which commands we are using, we can make it shortcut from this customized toolbar. Okay, and yesterday I explained you this one about toolbars, restore and all container restore positions. And here we have one more command like lock toolbar positions. So actually, sometimes when we are working, so we can place some comments here. Okay, everything will come to restore here, but I want to keep where I want. Like I want pad command here, fillets here, and these points here. Okay, and also I want graphic properties here, and sketch also here. Okay, I want to lock this position means you can just go to customize. Okay, and here option we have, and here we call like lock toolbar positions. So if you check this one, these positions won't go anywhere. It will stick on to this position only. So if we are daily using few commands, so we can place it here and we can lock the position. So next time if you close and open, it will come to the same position. Sir, is it clear, right?
Yes, sir.
Yeah. And here we have graphic properties. You see, I lock the toolbar position. I'm not able to drag this toolbars into my window. Okay. Here also it will all will like inactive. And go to customize here. And again, uncheck this one. You see, this time I can drag the commands here even these features also activated. And coming to this graphic properties, here we have a colors, and here we have like transparency. So I want to create this color, this phase with some other color. You just select the face, or else you can just select the body and you can give any color. Okay. But if you want to give any color to these individual phases, you should not select the body. You should select the phases and then you can give the colors here. I want this. Okay. I want this in transparent. So I will select this feature. Here it is 100%. I'm giving 50 or 25% also. Okay. Now it looks like transparent. So, and then coming to this one, this is line type we have, and here also line type. This is line thickness actually, and this is line type, and this is the points. And in graphic property, we have a one brush painter. Okay, it is like and just copy and paste the color to the page. So I don't know the color here, and I want to color this face with the existing one. Just I will select the face and take a brush and select this color. So automatically that color also will come to the selected face. And here we have undo, redo, save. Okay. Mm. Next, coming to this one, here we have a save, save as, save all, and save management. Generally, we are using control as like to save. Save as already you know that to make a or to rename the part or to get a copy of that part, we are using save as. Save all, like in a product or in a tool, if few parts are there in the window, if you select save all, so all the parts will save into the folder, and this is called save management. And here actually in assembly levels, I will show you once I will start the assembly workbench. Here actually save as we have, and we can change the folder also here. So I'm changing the path. If any parts which are linked to this product, all parts will move on to that folder by taking propagated directory. Sir, is it clear regarding save options? Sir, is it audible, right?
Sir, audible, sir.
Yes, audible, sir.
Audible, sir.
Yeah, okay, sir. So this is all about like part modeling. Just will practice few generative shape design commands. Here, if you go start here, so all workbenches will be displayed here, like whichever you want, like part design, assembly, sketcher, array drafting. Okay, and here we have a shape, and this shape is called like generative shape design. This is like a surface. You come to here, so you can able to see all the surface commands. Okay. You can take Control N or a file new. In surface also, we have these surfaces. This is like an sketch-based features. So this is extrude, and this is offset, and this is sweep command. Okay, and this is fill, multi-section surfaces, and a blend. So coming to this extrude, it needs one sketch, okay, and the direction. So first I'm taking this one, just I'm drawing one line or a curve. So you can use profile also to draw a line or a curve. ISO constraint the sketch. So for this template shape design, for the extrude command we need open sketches. Even close sketches also we can extrude here. So here it asks for dimensions. Like it works like an extrude only, since pad only. So here you can give a mirror extent, or here also you have up to element. So this is a simple extrude command. And here we have a revolve command. Just I'm making these lines in construction line. Just hide this feature. I'm using the same sketch for this revolve command, and I'm selecting this profile, and I'm selecting this axis. How much degree you want you can give, like same as shaft command in the part workbench. So this is about extrude and revolve in the surface command. Next, coming to sphere. For sphere, for creation of sphere, we need one center and the radius. We select the point, automatically it asks for sphere radius. So I want 50. So and here we have an angle. Create the sphere by specifying angle. If you don't want to specify any angle, you can just select here, create the whole sphere. So it will create the whole sphere. And coming to cylinder, here point, select the point, and direction it is asking. Here right click, and which direction you want, like XYZ. You just see this compass here, it's showing Z in the up direction, Y and X here. So in which direction I want? Suppose I want in X, you see, in this direction it will extrude. And if I want in Y direction, and if I want in Z, so it will come in Z direction. And here it is asking for the inputs, like radius, how much you want, 25, and the length 1 and length 2 from the middle of the point. So here you can give some 30, okay, and here how much you want you can give, here like 10. So this is about extrude and revolve option in the surface command. Sir, is it clear?
Yes, sir. Clear, sir.
Yeah, okay. And coming to this one, this is an offset. So I want to offset this curve. I can use this command offset, select the offset command, and select the surface you want to offset. So I want to offset this cylinder surface. Just I will select this surface, and I will give the input, like how much offset I want to do. Like I want 50. So it will offset to 50. Automatically this dia will also change regarding this, like by using this offset command. So if I want, I will select this surface, and here we have few options here. Both sides and repeat objects after OK. So just I am checking both sides now first. I am checking with first one, offset. I am just selecting the surfaces. After that, it will reflect here. Like these commands will activate here, and I am selecting both sides, and it asking the offset value. Now I am giving 25. So it is not coming because this dia is lesser. Yes. So here I am giving like 50. And now I am taking offset surface both sides like 25. Okay. Sir, is it clear offset command? Sir, is it audible, right?
Sir, audible, sir. Clear, sir.
Okay. If you have any doubts, just let me know.
Yes, sir.
One more option in offset command. Here we have repeat object after OK. In the sense, I want some 10 instances with some offset distances. So it will create like this. If I check this one, okay, and I'm giving this offset of 15 mm, and I'll click OK. It will ask for how much instances, like how many instances you want. So suppose I want 10. See, okay. So this is the offset command. So how you want, you can use this one, this command while developing models. So these two should be very useful. This is about offset command, and this is sweep. Sweep is nothing but just like an rip command in the part modeling. It needs 2 sketches and 1 guide curve. So for hide and show, you can use space bar. And actually, I want to create a plane here. I want profile which is normal to this curve. So I want to create a plane. So here take a plane, okay? And here we have many options. Yesterday we used only this option, offset from plane. And here we have normal to curve option. You can just select this one, select the curve, and select the point where you want to create a plane. I want to create a plane here. Okay. Sir, is it clear this command? How to create a plane in normal to curve?
Sir, yes, sir.
Yeah, okay, thank you. And then I want to create one profile here. And yesterday we used only the sketch command, and one more we have positioner sketch. Just to check the difference, I'm taking this just sketch and select the plane. It will come default to this like orientation. But I want different orientation means you can just see this curve come in this direction. For normal sketch command, I want position sketch. I will select this plane, sketch positioning, and here we can define the origin also. In positioner sketch positioning, in origin type we can define the position. So here we have a projecting point. You can select this point. We can select this curve. Automatically this origin will shift it to that point. Okay, and here actually generally now we have like this horizontal. This is horizontal and this is vertical. If you want to change the view means you can just flip on this one. How you want, you can just rotate the horizontal, vertical, and then keep the view. So before normal sketch it came like this. Now I want in other direction. I will take the curve. You see, this curve is flipped 180 degree, right? This is the difference between normal sketch and the positioner sketch. Now my sketch is not in sketch orientation, so I can make it by normal view. Okay, here I want a like hexagonal or a circle. So I create this profile and we can select the sweep command and we can just select the curve here and this path. So if we check preview, it will create the pipe like this. Sir, is sweep command clear?
Yes, sir.
Okay. And in sweep also we have different commands here. And here we have one more command. In swept surface definition, we have a circle command, and generally we have this one explicit, and it needs two sketches. One is profile and one is a path. And for this one, the circle sweep command, we need only one path, and radius we can give direct here itself. Here actually we can get only the round faces, like a circle or a arc faces. But in this command, whichever you want, profile like hexagonal or a rectangle, that you can get it by this explicit. So for in this circle, I'm just selecting this curve and I'm inputting the radius here. So you will get a sweep option. Generally, this option we are using in developing exhaust system connecting pipes. So this is about sweep command, and this is about fill command. The fill command is nothing but like filling the surfaces, gap surfaces. Here actually it is opened here. Here also it is open. So I want to close this one. Again, I don't need to draw any sketch and extrude that one. Just I'm directly select this fill command and I will select this surface. It should be a closed contour, then only it will fill. Okay. Then just to check preview, so it will close. Okay, this is about fill command. And here also we have split, trim. Okay. Here also we need one plane array surfaces to split the body. So just I will draw one sketch here. So the difference is clear, right? Between sketch and positioning sketch.
Yes, sir.
Between these two.
Yes, sir. Yes, sir.
Okay. And here I want to split this pipe with respect to the surface. Okay, and take a split command. Select element to cut. In the sense, for which part you want to cut, and in which way, like a plane or a surface. You can just select that one. So it will ask whether which direction you want to cut. So here it's showing like other side. Which side you want, you can just select and then press OK. Okay. This is called split command. And this is about split command. And the difference between the split and trim, here we have trim. So Actually, for this one split command, we can able to cut with respect to plane also. But for this trim command, we must have two surfaces. For example, this one. Now you can just check this one. The split is only cutted the surface removed and it is fully blank only. And if you check with this trim command, you use Control Z. So I want to close this pipe and end to here. Take a trim and select the body and select the plane. So now it is asking like same other side or next side. Okay. You see now this side. I want this pipe to be closed. You see. So the trim surface will become like this. So is it clear? This trim and split.
Yes, sir.
Okay. And here if I want to change other side, I want close by inside. So I will take it here and I will close like this. So the remaining all will trim and it will give the final required model. So this is about trim and split command. And here we have a fillet, same like part modeling. Here I am giving this thickness for this fillet. Okay. And if I try to apply fillet on this one, it won't take because this is different phase. This is fill phase and this is a trim phase. So we should join these phases, then only it will allow us to give the fillet. So this is join command. Okay, here we have a join command. We can select this one and select this phase. So press OK. Then now if we try wedge fillet, it will allow. Okay. Is it clear regarding join
Yes.
fillets? And now I want to give a thickness to this part. So when we are developing such surface-based models, come to part design. And here you can use these commands now. First I will take thick surface and I will select this face. It is asking like inside or outside you want it. So if you reverse the direction, it will go inside. Outside the direction, it will come outside. Okay. And your surface model should be clear with such fillets and smooth curves. Check here, inside it is hollow, right? So this is about few surface commanders. And here we have boundary and extract. If I want to extract surfaces from the solid body, you can just select this extract and select the faces you want to extract. I want to extract this face, this face. We can go to here. We can just add the surfaces to extract. Okay. Sometimes, when we are doing reverse engineering, they will give one solid model like this. And with respect to such solid model, we need to extract the faces and develop a parametric model. And here we have few more options called in extract definitions. We have point continuity, tangent continuity. Okay. If I give tangent continuity, the complete curve is set because all surfaces are tangentially connected. So next chamfer. So here I want to give some chamfer. Command will work like an part modeling only. There is no difference in that. Chamfer. Here I am giving distances how much I want, like 5 mm. I will give. This is about surface chamfering, and this is also like symmetry. It will work like same as part design. And here I am extracting this face, and I want to enlarge the surface with respect to this plane. So here we have extrapolate, and just we are selecting the space. Extrapolate. Select this surface and give the length how much you want to enlarge that surface, like 10 I want or 20 I want. So this is about extrapolate, and few more regularly used comments are here: the projection, intersection, and the parallel curves. I will explain now. And here we have option called parallel curves. And take this one and select this R, and it same works like an offset. So you can give it y. So actually in offset command, we can offset the surfaces, and here we can offset the curves in the edges of the surface. Okay. So this repeat object after OK also same as offset curve. Sorry, offset surfaces. I'm selecting this curve. Again, it will ask for instances. How much you want? Like there is no. Here offset reverse direction, and here okay, that will be 5. So it creates offset curves as like this command, offset command. This is done. This is done. And here we have an intersection. So here intersection, select first element and second element. It creates a curves in the intersection of these two surfaces. Is it clear, right? Sir, is it clear?
Sir, yes, sir, clear, sir.
Yeah.
Ready.
And this is about this intersection, and this one projection. So actually I have one point here. I have one point here. I want to project this point on this curve. So that projection, select this point and select this surface. Select this projection point and then support. So that point shifted to that surface by using this command, projection point. So these are the major commands generally we are using while developing a models. And so we will develop one spring. We are going to helix. So revolutions 50. Meter 50. And here we can change the pitch value. And again, if you want to create a spring, just take a plane, normal to curve, select this curve, and select the point, the end point. Here you can change the height and pitch, height and revolutions. Okay, height and revolutions. Height will be 30, and revolutions will be around 30. Height is not. And then it should be like 50. And now we have to draw profile for a spring, whether it is an hexagonal or a spiral, like circular spring. Same like projection point. Select this point and press OK. Here, so now by using sweep command, you can just select this profile and the guided curve. So now you can see the spring. So it looks like contacting each surfaces. So we can here increase the or change the helical definition. Okay. And here few more options we have: taper, inward, outward, and if you want any taper in the angle, you can give that. If you want to change profile, suppose I want hexagonal. I'm taking position sketch. Here, projection point is here. And this time I want hexagonal profile. So same sweep command, hexagonal profile and the curve. Okay. So this is we can create the spring like this in 3D. And I want to create thickness for this one. Coming to part design. Okay. Same like closed surface. You just select this one and select this. You see, our spring model is ready with solid material. Sir, is this clear, right? How to make an helical spring?
Yes, sir.
And this is spiral option. Diagonal will be 60. And end radius I'm giving like 60. That is spiral reference. Start radius is 10. And here we can change the revolutions. Okay. Sir, is it clear? This helical and this one spiral. And here this is normal 3D spline. We have 2 points, you can draw that one. Create 1 point. Let us spline here. And for this spline, we can add a point here. Add pointer before. So add point after this point. Conquer. Let's create a point here. And now and you can reorder the features by right click here, reorder. So wherever you want, you can just reorder this one. You can select this one, and here it is asking whether before or after or inside you want. So I want this point to be defined after this point 6. So after this, This cannot. Create a plot on a curve. This we will discuss later. And so major commands we covered in generative shape designs, and I will show you coming to part tree structure. And here if you go to tools, options, some general setups we should take it initial steps. Like here in general we have data save option. No automatic backup every 30 minutes. Okay, generally we are using it no automatic backup. Why? Because if you keep automatic backup, so if you do nothing also for every 30 minutes, it's going to save. Okay. Default we can keep this one as no automatic backup, and in part infrastructure, here we have enable hybrid design inside part bodies. So if I take any new part, it is asking, it is enable hybrid design or what? So this part is hybrid design enabled. So all your part features, just observe here. This is an part body feature, okay, and this is a surface features. Both are come under same tree. When this enable hybrid design is enabled, this hybrid design is enabled. If we uncheck this one, I will just show you. If I uncheck this one, now I'm doing some part design here. So this part body, it has only the part modeling features. So now this part is hybrid design is not enabled. So if I go to surface, if I try to do any surface commands, this if enable design is not checked or not activated, this will create automatically geometrical set. Have you observed this one? So if I do any surface finish like generative shape design operations, it automatically creates a geometrical set under the part body. So this is when the enable hybrid design is off, and this is when enable hybrid design is on this time. Okay, sir, is it clear about enable hybrid design while taking new parts?
Yes, sir.
So this is about the enable hybrid design and like enabling and disabling. So it will create a geometrical set, whichever the features you use by like surface workbench. Suppose if you give fillet or something, anything you use, it automatically create a geometrical set under the part body. Sir, in part design and generative shape design, everything is clear, right? Comments?
Yes, sir. Clear, sir.
If you have any doubts, you can just ask me, because in afternoon we will going to start assembly design. If you have any doubts, so just let me know. I will try to solve that problem.
No doubt, sir.
Dear participants, feel free to ask any queries regarding the parts drawing, any editing comments and all these things. Ranjit?
Sir, no doubt, sir. No doubt.
Yes, sir. Everything is clear, right, sir? Regarding how to save the part and in part modeling and sketch. And a few more options we have here in tools options. Here by default we can keep some settings here. In general, it should be normally automatic backup should be there. Okay, and here in display, this is like a text. We can fix it with the text. The display text size that I will show you when doing assembly. And here in parameters and measures, you can change the units here for a mass or a length or angle. So there are some general settings you can do. And here infrastructure. And here we have one option called cache management. Actually, in our CATIA, it takes too much of graphics load to display the assemblies. So in such time, we can use this command, work with cache system. So it will reduce the complete loading of graphics at that time. Whenever we want, in that time we can activate that design, and then we can look over it. And here we have material library, catalog editor, and here part infrastructure. Here actually we have in part infrastructure, we have few setups here, and generally display command, it will give, if I check this one, it will show parameters here. And here in part for document, create an access system when creating a part, and I'm checking create a geometrical set. If I check and save this one, when I'm creating a part, automatically this access system and geometrical system will create. So now if I try to create a new part, okay, you see one geometrical set will come and default one access set will come, access system. So this is about the setting. If you want to do, you can do this one, create an access system. Generally in aerospace domain, they are working with access systems only. So in such domains, if you choose, you need to know these settings. And one more option we have here, like update. So whenever we did some errors and it is not able to solve by CATIA, it shows error. Just yesterday also I shown you, I think, in part modeling. So if I try to pad this one, so you must use thick operation like this, it is showing. If I put OK also, it won't take. For some features, and I want to pocket some profile here. Actually, this whole part will changes into red color. In that time, we need to give update here. And suppose if I remove this face, it is not able to remove. And one more option in sketch command. I want to draw a sketch on this one, and I want to project this curve as a drawing lines. Here we have this command 3D geometry. Okay. In that, here we have project 3D element, intersect 3D element. Okay. Generally, we are using project 3D element. So already we have an existing surfaces, and with respect to that surface, I need to modify some profile. So in such cases, I will just take this one and I will select the edges. So it will create with yellow line. So yellow line in the sense this is a reference element, it's showing that color indications. Okay. So, and if I want to modify anything, I can just so the next feature will use the extracted line as a standard geometry. If I want to extrude or something, you see. So this is about the command in sketch. Project 3D element. So this one frequently we are using in the modelings. And here we have few more commands like, I think I explained actually. If I select this line and I select this translate, we can move. And here also we can give the instances. And this is like rotation. How much you want, like how many instances you want. You can use like a pattern. And here this is also scale. I want this line with some scale. So here how much I will add, it will come like this. And this is an offset line command. So I want to offset this curve. So I will select this line and I will offset. So how much distance you want? 3 or 5? Okay. So I think we covered all commands in Sketch as well as in part modeling and also in generative shape designs. If you have any doubts, just let me know. I will try to solve the problem. Is it audible, right?
Audible, sir.
Sir, anything doubt means you just ask me. Feel free to ask any issues or any problems you are facing while doing sketch or a part modeling. So afternoon session we will go to this assembly workbench. There is no issue in part workbenches, right?
No doubt, sir.
Yes, okay. We will continue assembly workbench after the lunch. After the lunch,
Okay, sir.
just we'll have a lunch break now. 10:30 we will start the session. Sorry, 1:30.
Okay, sir.
Yeah, okay, sir. Okay.
Okay.
Guru sir, thank you very much, sir, for your wonderful presentation.
Thank you, sir. Thank you.
And dear participant, the next session will start at 2 o'clock, a purely assembly. So pertaining to this, so far what we discussed, any doubts, just feel free to ask and get it clarified.
Shall we take lunch break?
Yes, sir, lunch break. Urgent for lunch break. So next session will start at 2 o'clock, sir.
Yeah, okay, sir. Okay.
Yes, sir.
Yes, sir. Thank you, sir. Thank you.
Rajesh?
बहुत beautiful. So, Vinod sir, ತಳಗ ಶಿಫ್ಟ್ ಆಗ್ಯದ ಕಾಂಕ್ರೀಟ್ ಲ್ಯಾಬ್ನಾಗ ಹೋಗಿ ಹುಡುಕ ಸರ್ ಇದು ರಿವ್ಯಾಲ್ಯೂಷನ್ ಅವರೇ ಕೇಳ್ರಿ
No? Yeah. ಹೌದು. ಹೌದು. ಎಲ್ಲ ಓಪನ್ ಆಯ್ತಲ್ಲ, ಓಪನ್ ಆಯ್ತಲ್ಲ. ಹೌದು. ನನಗೆ ಸ್ಕೂಲ್ ವರ್ಕ್ ಫ್ರಮ್ ಆನ್ಲೈನ್ ನಡೆದವ, ಆನ್ಲೈನ್ ಟೀಚಿಂಗ್ ನಡೆದದ. ಏನಿಲ್ಲ, ಅದೇ ಮಾತಾಡ್ತಾರೆ. ಹೋಗಿದ್ವಿ, ತಲೆ ಕೆಡಿಸಿ ಹೋಗಿ ಮಾಡಿ ಕಳಿಸಿ. ಏನು ಅದೇ ಈಸಿ.
Sir, shall we start?
ಮತ್ತಕ್ಕೆಲ್ಲ ಆರಾಮಲ್ಲ. ಹಾ. ಮತ್ತೆ ಎಲ್ಲ ಸ್ವಚ್ಛ ಆಯ್ತು. ಮತ್ತೆ ಯಾವಾಗ ಅಂತ ದೇವರಿಗೆ
Guru sir,
Yes, sir.
we can start, sir. There are about 40 participants, and others
Yeah.
will join in some time.
Okay, sir. Okay.
Okay, sir. Thank you.
Yeah, thank you. Good afternoon, all. It is audible, right?
Yes, sir. It's audible. It's
Yeah.
audible, sir.
Now you are seeing my screen, right?
Yes, sir.
Yeah. Okay. Thank you. Anyone having any doubts or like any difficulties in part modeling? No, right? If you have any doubts, you can just ask me. So shall I continue to assembly workbench?
Yes, sir. You can continue, sir.
Yeah, okay. Thank you. So when we open CATIA, actually it came like assembly workbench only initially. If we close also, so the default opening position with assembly workbench. So if you close also, you can go to here, file. Here we have a assembly design. If you just select this one, it will come. So this is then product in the sense assembly part. So here actually in CATIA product we call it like assembly, like assembly part in the sense like the main product. So inside this one we need to create a parts or we can add a parts. Okay. So if your commands are similar here, the same like these views, hidden views, these are all similar only here, same commands. And here we have product structure tools. So this one in product structure tool, we have component here and product and part and existing component with positioning. This is a replace component and this is graph tree reordering, and these are generate. Majorly we are using only these 3, 6, 7 commands. Okay, and sometimes we are using this also like instantiation. I will show you how we can use this one. So this is a component and this is product. So the icon is different here. The component is an like it is a dependent format. In the sense, it won't save in the folder. If I'm trying to save this one, so I'm changing like assembly 1, and this one I'm changing like assembly 2. In assembly 1 I'm saving same path. So this is an dependent format and this is an independent. That means that, so this component, actually this component, we're not able to save inside the folder. It is only reflects in the CATIA tree. So this we can save inside the folder. So this we can save independently. If you try to save this component, so it saves the main product which is linked to that component. Is it understood, sir? So if you save this also, only main product will save. Is it clear with component and the product? Sir, is it audible, right?
Yes, audible, sir.
Yeah. Is there any confusion between the component and the product? Is it clear, right? What I explained now.
Okay.
Clear, right? This is component is dependent one, and this product is independent. We can save independently into the folder, and this component only it will reflect in the tree, and it like it acts as a product also. So you can insert a component or a product inside this one. I can insert a product inside this component. Okay, it works like a product only, but we are not able to save inside the folder. So this is the major difference between the component and the product. So these two are clear, right? And we are coming to part. So this is the main product. Let us say assembly one. I'm save as here. And I want to add a product here. This is the main assembly, and I want to add on sub product here. And here I want to rename it with some like sub assembly one. And here in properties, in the assembly structure, we have two. We have to input two namings. One is like part number, and another one is the instance number. So the part number and instance number should be the same with this dot one. Like it's showing that how many instances you used in a tree. Just I will explain you. Just observe this one. That one I'm pasting here. And I save this product. So if I copy and paste it many times, okay, the instance number is getting increased 1, 2, 3, 4. You notice it, right? So this is like instance name. So this is the instance name. Here it is 1. If I use the same product in a sub assembly, like this is going to change like 1, 2, 3, 4. Is it understood? Tree structure? And coming to this sub assembly, I want to create one part here. So for that one, new part here in product structure tools, here we have a part command to create a new part inside the assembly. So if you select this one, inside this sub-assembly, it is created. Wherever you creating part, that product should be activated. So I activated this part, like double click this part, and I've created a new part here. So if I want to create outside this, like under the main assembly, you can just activate this one and select this command. So automatically it will create the part under the main assembly. Is it clear how to work with sub-assembly and main assembly? How to create a parts?
Yes, sir.
Okay. Then you can create a part here. So you can create a part here, like then if you double click on it one, it will automatically enter into the part workbench. Here you can take a sketch. Create a part. So I'm creating one part here. Okay, and I'm using this dresser features also. Wherever I want, I'm giving fillets. And I'm giving some surface colors. Okay. And if I want to make a hose, I can make it inside the part. And I'm using pattern here. So morning, as I explained, so this is like flat hole it is coming. If I check this keep specification, so it will come to V bottom. And again here I'm going here, check template, take metric thick pitch, and define the hole distance.
Then, Brahma.
So if you want to make changes to any holes or any features, you can just select that features, and here in graphic properties you can change the colors. So this is created a part inside the product. Okay, is it clear? Sir, is it clear, right? How to create a part inside the product?
Yes, sir. Clear, sir.
Yes. So already if I have any part means already we have in existing folders, we already created a part and we need to call into the assembly. So in that time, here we have a command called existing component. So we can select this existing component and select this assembly, like which sub assembly you want to add a component. Select this one. It will automatically open the file selection. So I have one standard part here. So I want to constrain this clamper into this part. First we can fix this part. Here we have a constraints. Okay, this is a coincidence and this is a contact constraints and this is offset and this is an angle constraint and this is fix. First part we need to fix. So from this part we can assemble all remaining parts. We can take it this one as a reference and we can start assembling the parts. Is it clear? Sir, is it clear?
Yes, sir. Clear.
So this is about how to take an existing component from the folder. And this is replace component. So I want to replace this clamper with other part. That time, select the part, replace component here. Okay, or you can select three itself. Here, select the part, right click. Here, component, replace component. So I want to replace this part with any other part. It is asking, do you want to replace all the instances of the selected element? While you are replacing, suppose if I am putting few fasteners like bolts and dowels, if I am trying to replace any one dowels, it asks like this. We want to replace all the instances of the selected element. If I give yes, it will replace all the instances which are inside the assembly. If I say no, it will replace only that part. You see, it came here. So again, if I want to replace this part, select, right click, components, replace component. No. If I say yes, These both will replace. You just check. You see, this is also clamper. This is also clamper. This is clear, right? Replacing component.
Yes, sir. Clear, sir.
Okay. Now I want this one as NC. Just replace component. Now I will say no. Then only one part is replaced. So this is about how to replace a parts or a component or a product in the assembly. And this is tree reordering. I will call few more components and I will show you. So this is the standard part, like pneumatic cylinder this is, and this is in the clamper. So, and this one is tree reordering, graph tree reordering. I will select this assembly and I will select this graph tree reordering. It will show, it will open one window. So here you can reorder the tree, like upside or downside. And this is I want to go up. So I will select this one and I will click on this. So it will select the picking points. Like this we can do the graph tree reordering. See here it is changing. And coming to this one, fast instantiations. I will show you. I will call on standard part here. And one more thing, for your practices in CATIA inbuilt, we have this catalog browser. Okay, you are getting this one, right? Here we have catalog browser. In this you will get the ISO standard bolts, keys, nuts, pins. Pins means these are double pins. Screws we screws we have, and also washers we have, nuts, bolts. If you just double click on this bolt, so again it will go for different grades. It is showing like ISO 4014 hexagonal bolt, C hexagonal bolt, this one. So again I'm selecting this one here. Okay, I want M8 bolt here. Here it's showing M8. So just I will select this one, and here it will come. You can just press OK and cancel it. So one bolt we added. Just make hide and show. Okay, you see. So this is standard bolts which are available in CATIA default, and this may be different to different country projects. Some people using British standard boards in the inch system, and generally ISO standards we use in system. Sir, is it clear how to take a standard parts from the catalog?
Yes, sir.
Okay. And I want this bolt, I want an extra copy of this bolt. So I don't want to again go and open this one. I will just select this one, or it's showing the shortcut Control D. I select this one and I will select this bolt. Automatically it will give one more instance.
Sorry for the interruption. Guru sir,
Yes, sir. Tell me.
can you select BIS standard just like that? ISO, ISA standard just like that?
BIS, ISO.
BIS standard, Bureau of Indian Standard.
Okay. I think in CATIA we have only this ISO boards. Not able to
ISA
follow.
standard,
Yeah,
ISA or BIS standard.
no, but in this default library they will give only ISO. One minute. I'll check here.
Because every time you cannot take ISO standard. Sometimes BIS standard required, ISA standard is required, just like that.
I will check 1 minute. Yeah, here we have ANSYS standard, ANSYS standard. Is it okay? And if you want any different standards means, here you can change ISO, US standard, and EN standard, and this is JS, that means this Japanese standard. So this is also EN ISO standard only. And this is like, open this one. Actually, this is an ANSYS standard board with M18 to 40. The model is a bit different here. Sir, is it clear?
Threaded profile you can't say, sir.
Huh? Threaded profile.
Thread profile.
Thread profile, sir, 3D ಕಾಣೋದಿಲ್ಲ ಇದು.
Right.
ಅದು ಆಕ್ಚುಲಿ 2D ಇಲ್ಲಿ ಇದೇನೋ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಇರುತ್ತೆ, ನಾವು ಜಸ್ಟ್ ಅದನ್ನ ಯೂಸ್
Voice.
ಮಾಡ್ಕೊಳ್ತಾ ಇರುತ್ತೆ ಅಷ್ಟೇ.
Okay, right. Okay.
ಓಕೆ ಸರ್, ಓಕೆ. And if you want to open any part in new window, you can just select that part, right click, and here you will get open in new window. Okay. So and here also you have many properties. Like if you select properties, it will show the properties of that part. You show hexagonal bolt head and few parts having other properties. If it has, it will show here. So now we will call dowel pins. So here we call it pins. So dowel pins also called like parallel pins. And so here we have parallel pin. Okay. So this is about catalog.
Hey,
This is a inbuilt catalog in CATIA for a fasteners or a dowel pins or some other nuts. Okay. So if you want to instance that one, you know, just select this one and select this part. Automatically it will instant. So this product structure tool is clear, right? Majorly we are using only these commands. And coming to constraint, shall we move to constraint, sir? Is it clear, right? Product structure tools?
yes, yes, sir. Yes, sir. You can proceed, sir.
Yeah. So here we have coincide constraint. This is a contact constraint. And here we have a offset and angle constraint. Come to coincide constraint. From here. So I fix this part. Whatever the constraints you did, it will reflect in the bottom of the product. So it's showing like NC fixed. So I fix this one as a reference, and from this one, I'm building a assembly. Coincide. So I'm giving from here to 1 minute, I'm facing some issue with the CATIA. I will just get back to you in 5 minutes. Is it fine, sir?
Sir, okay, sir.
Yeah. Actually, we have some issue with that model. So I will just make other parts and I will show you how to do the assembly. So again, you can create a part here. Actually, coming to assembly, so we have constraints, coincide constraint. Here we can just select the phase and this phase. So it is asking. If we give OK, and it asks for update here. Okay, if you give update, automatically it will move to that phase. And also again we can use coincide constraint from this phase to this phase. Okay, update. And from here to here, you can use the same. If you update, it will fix like this in the part. Is it clear? How to use coincide constraints? Sir, is it clear?
Yes, sir.
Okay. Next, actually, whatever the constraints we given to part, it will reflect on the tree in under the constraints. So same part we can constrain it by different ways. So actually, if you want to check whether that part is constrained or not, here we have analyze and constraints. And if I select this part, it will show here, shows here. See, it shows like only the degrees of freedom for these fasteners. Degrees of freedoms are free for this fasteners. Remaining are fixed. And one more we have. Here we have degrees of freedom. And if I select this part, and then I select degrees of freedom, it will show like this. So anyway, this part is fixed. If I try to check this one, so it shows there is no such degrees of freedom to that part. So the same constraint we can give using by different methods here. So this is so first we use this coincident constraint. We have a contact constraint that is depend on the assembly parts. The required constraints we can use. There is no specifically we can use only this, only that. Not like that. We can use either coincidence or contact constraint. So I'm giving contact this phase to this phase. And if I give update, it will come and sit here. Okay. And if I want to give, so I give a surface contact here, that constraint. If I want to change any other constraint, we can just select that constraint, right click, go here, and here we have a command called change constraint. So select this one, and whether in which way you want. Actually, this is we give like surface contact, face to face contact. we give, and I want like offset. So I will select offset, and here I can give a value. If I give update, that part will lift up for 10 mm. Is it clear? How to change a constraint method? So then, coming to this one, this is an offset constraint. So you can fix the part from this phase to this phase. So now it is 0. I want to fix this with 5 mm. So if I give update, it will move. But I want 5 mm outside this direction. That time you just click on this one, go to constraint definition. If you select more, here we have option called same, and you can check select opposite. And if you give update, it will move this side. Okay. So next, coming to this angle constraint. So I want to keep this phase and this phase around 45 degree. Give update. This phase and this phase will shows 45 degree. And I want to constrain this part from this axis to here. It has 89. I will give like 10 mm. Okay. And again you can give here offset command this part to this phase. You can give 5 mm. So this is clear, right? About constraints. So these are the major commands we are using in constraints. This coincide, contact surface, offset, and angle and fix. Sir, is it clear, right?
Sir, yes, sir.
Okay. And we have one more toolbar here that is called move. Here we have manipulation. So we can move the part in whatever directions we want. I select this one, but it won't be constrained. It will be free only. The part will be free only. You just select the part and you can select the directions, which direction you want. See, only next direction only it is moving. Just observe this one. Here it is X, right? It's moved in this direction only. If you select Y, it is in Y direction only. You see here Y direction. If you make it in Z, this is Z only. If we want in any other like incline or any other directions, we can just select this one, drag along any axis. Select this one and select any lines. Either like this you want or like this you want. You just select the line and move the part with respect to that axis. Okay. And here we have a rotations. I want to rotate around the X. So if I try to rotate, the part will rotate on the X direction only. Okay. See, this is the X direction and this part will rotating like this. Same like translation. Okay. Same X, Y, Z also same only. Okay. And again, one more we have here, like drag around axis. If I take any corner or any line, so it will create a rotation axis for that part. Okay, with respect to that axis, part will rotate. And here we have like in two direction we can move x and z, x and y here. I'm not able to move like this, but I can move in the x and y direction. Okay. So majorly we are using top 4 and bottom 4 for rotation and translations. Is it clear about this manipulation command?
Yes, sir.
Okay. And we have one more using command is like snap. Okay. We don't know the part where it is, and we can just select it in the tree. And if you select this one, we call like snap, and here we call smart move. So this is just a snap means it won't create any constraints, but we can move a parts from here to here. I can move a part. You see part is moved, and again I select the snap, and I place this bolt here. Okay, but it won't create any constraints. Is it clear? Between constraints and the snap command. If you are finding any difficulties or confusion, just let me know. I will clarify.
Sir, how do we know that whether it is snap or constraint?
Actually, if you do snap, okay, it won't create any constraint. Okay, and this is free only. Now, if you check with degrees of freedom, this is free only. Okay, so if I fix this one, so I will move using manipulation command, and I will move this bolt here. Okay. So now if I try to constrain, here for snap command, there is no constraint. And for this one, definitely under the constraint, it will create a constraint command. Like coincide I'm taking here for this whole axis to bolt axis to this whole axis. Okay. And offset I want or bolt snap I want. Here we can use both like constraint, contact constraint, or a offset. See, once I use constraint command in CATIA tree, it will reflect coincide and offset I used here. Is it clear?
Okay, sir. Okay.
Yeah. And here we have one more option in snap command. If I select any part and if I select smart move, it will open in window. It's open in small window. Okay. If you're not in a big assemblies, we are not able to see the parts where it is. In that time, we can use this command. Smart move. You can just select the part and use the smart move. So automatically it will come in a small window. So from here, you can give a constraint to that part. From here to here, this axis. Okay. Clear, right? I move this part from here to there, but it won't create any constraints because I use snap command, right? So these are the major and mostly we are using these commands only while we are doing assembly. And one more I will show you. See, I am moving the part, but still I didn't get any constraints here. This is a manipulation command. You want to move this part, and if once you give the constraints, if you move or replace the part, it will ask for update here. Okay. If you give update, it will move to this constraint position. And this part I didn't constrain, so if I move also, it won't affect. It won't ask update. So I move this part. You see, it won't ask update. Why? Because I used snap command to place that part. So if I use same for constraint, okay, and if try to move this part, so if I move that part, it didn't ask update because this part only constrained in this direction, in Z direction. Okay, is it clear? Sir, is it clear?
Yes, yes, sir.
Why it didn't ask update means we constrain this part in this direction, is that direction. So now if I take the same thing and from here to here, and from this face to this face, okay. If you give constraints to the part, if you move or if you replace or relocate, it will ask for update. You can just check this one. If you try to move in this direction, automatically it will ask for update because it already constrained with some values. Okay. Is it clear with snap command and this constraints? So now we'll check other assembly commands. Now I move a bolt here. So it didn't ask any update because I deleted all the constraints. And now I will make some holes here. Like features, how you want, you can create, you can use like dress up features. So I want chamfer all around the part. So I will give like 3 or something chamfer here. I will make holes here. And here I use pattern. I will create 3 holes here, and then second direction I will create 3, spacing of 15. And here also I will place 15. So I want to put a double holes here, double pin here. So this is the parallel pin. So I'll just take this one and I'll snap here. Okay. So I want to put dowels to all these holes, but I don't have time to snap every dowel to the hole. That time we are using here reuse pattern. So in that, select this dowel and select this command reuse pattern and select the pattern holes. So here it will ask so if I snap this, here it will fill complete hole because I place the dowel here and it will take the same pattern but it will start it from here. So select this dowel, select the reuse pattern, select this whole pattern. So now it's filling correctly because first dowel is fixed inside the first hole. So it fills the whole, the complete pattern. So is it clear? Sir, is it audible, right?
Yes, audible, sir. Audible.
Is it clear, sir, about this reuse pattern?
Yes, yes.
Okay.
Guru sir,
Sir, tell me, sir.
after entire assembly is over,
Okay, sir.
can we show assembly in one side, dismantle parts in another side?
In 3D, sir.
No,
Okay.
3D is one
Then,
part.
okay.
Yes, yes.
Exploded view you want, right?
Yeah, yeah.
Yeah, okay, sir. Okay. I will show you. I will assemble some parts and I will show you, sir. So this is
sir, one
about...
more doubt.
Yes, sir.
Can you show me after completion of this how to convert all the 3D model into 2D drafting?
How to?
Convert from 3D geometry to 2D.
Sir, 2D tomorrow we will discuss. Actually, we kept a session 2D for tomorrow.
Okay, sir, fine.
Today we will develop all these assemblies and tomorrow we will discuss about the drawing, sir.
Okay, sir, fine.
Yeah, sir. Okay. So this is about this constraints. Majorly we are using these commands only. And this move and for explode, actually here we have explode command. If we select this one, select this assembly. So if you want to modify that one, if you give constraint, after exploding also, if you give update, automatically all parts will come together. You see, we didn't fix this part, so it is showing here, but dowels are user pattern, so they are highlighting here. So now if I fix this one, this face to this face, finally this face to this face. Okay, like this, we can do exploded view. I will show you an assembled sub-assembly, and I will show you that how to explode that one. So this is one clamp unit for an fixture. Here actually in this way didn't use constant, actually everyone use fixed here. And if I want to explode, actually in some of the domains like exhaust systems, what they will do is they won't explode in this working window. They have called like scenes, enhanced scenes. So if I select, over partially, okay. And here they can able to explore the parts. You see, for this cylinder, all parts are exploded here. If I select this one, all exploded will be again coming to normal position. If we check this cylinder assembly, if I keep on increasing, scroll explode, it exploding too much. And if I'm reducing, it is coming near to that assembly. Actually, if we give proper constraints to the assembly, so we will get proper exploded view to the assemblies. Sir, is it clear?
Yes, sir.
Exploded view clear, sir?
Yes, sir. Clear, sir.
And now I keep OK, and I will exit this workbench. But in working window, it won't affect any of the parts. Again, if I want to go there, just I will click on enhance this one. If we already exploded, here we have called scenes browser. You just select that one. And select this one. So you see, in back side of the window, all parts are exploded, but in working window, it will be like assembled only. Sir, any doubts regarding this one exploded view?
No, sir.
No, right? So, and then I exit. So here, this will be the assembly, some small assembly. And here actually a few more options we are using in the industry. sectioning.
Guru sir,
Sir, tell me.
one more. You have shown exploded views. Individually, can you show the individual parts name in exploded views?
Individual part name.
Yes. Normally, in drawing exploded view, they'll show the individual component.
Yes, sir.
Just like that.
Sir, we can call, sir. In drawing, we can call, sir. Actually, I will show you here.
No. Is it possible?
Yes, sir, possible. I will show you here.
Yes.
If I'm creating new drawing, so I'm selecting this view. So this I will show you tomorrow, sir. I also forget this one. Sir, I will check with someone. I will let you know tomorrow, sir, about this exploded view drawing. Is it fine, sir?
No problem, sir.
Okay, sir. Actually, we have few more commands. We are using like space analysis. So in that, like clash and sectioning. So if in assembly level, if you want to see any sections inside the parts, like in big aerostructures, we're not able to see parts from the outside. So in such cases, we are using this command sectioning. If it's any big assemblies, so here we can give like in which direction you want to cut the parts. And here we have a volumetric one, volume cut. Select this one. This part will cut like in solid. So I want to keep orientation in proper direction. So here we can rotate like this one. And in result, if you do volume cut, you can see the inside of the assembly, whether some fasteners are missing or any some small components which are inside sub-assemblies. We can check by using this sectioning. And if you move this arrow, it will take you into the depth. So this is all about assembly commands we are using. So and one more thing we have in product in assembly levels. So actually I want to save this all parts in one propagate folder. So these are in different folders. So I want to propagate into the single folder. Here I am creating one folder. So this folder is empty now. So I want to propagate all these parts into that folder. First I will select this one, go to file, here save management, okay, and here we have this one, save as, and we select the folder, save, and here we have an option called propagate directly. So how this will work means, if you save top product in some path and you do propagate, the parts which are linked to that product, everything will be moved into that folder. Just see, propagate, okay. Now if you check propagate folder, you see, okay, all parts are came here. Sir, is it clear? Sir, is it clear, right?
Yes, sir.
And one more thing, you can observe that, like here in tree we have some different name, and here we have a different name. Okay, this is because of when we saving new parts. Suppose here I am changing, in tree I am changing something like and just I simply save this part. But while saving, it's showing like, if you take this part as save as, that time you will know that in the folder, this part name is saving in different name. Is it clear? So we should save the tree name as well as in folder name same only. We should not keep like this. So this is wrong method and it will affect the data. Is it clear, sir?
Yes.
Yeah. Now we can name it as bracket. So now in the tree, so if you go here in propagate folder, you can able to see the same name part bracket. Folder name and the tree name should be same only in CATIA tree structure. If you change only in tree and you just simply click save means it will take its old name. Okay. And one more comment we have here while we are doing assembly.
Guru sir.
Tell me.
Can we save the dismantle parts and assembly parts in the same file, same folder?
Yes, sir. We can save.
Okay.
So that is the way I showed you, like save
Yes, yes,
management
right,
propagate.
right.
Yes. So actually, I want to use this part with some slight modification. Suppose actually this part wants only some chamfer or some cut here. That time we have, if I simply copy and paste, okay, and if I try to modify that part, I hide here, and here I start working on this part. And here we can delete the fillets by using the remove face command. So I want some chamfer here. I modified only this part, but it affects original part also change. If you just observe this one. And we have one more command like the same part we are using with some slight modification. That time we have one command called, if you just copy this one and paste into assembly in same window, right click, here we have a command called paste special. Okay, if you select this one, here it is asking for break link. So break link means it completely like completely broken a link from that existing part. So select this one, select OK, and we should save this part with different name. Once you paste special with break link the parts in CATIA tray, it will shows like copy of that name. Now I am working this part. So I modify that part and I save this part in different name. Now that old part is same only. So is it clear? Because in some assembly levels, there is a chances of having same dimensions or same holes, and we need to modify with only some small chamfers or something. Means instead of taking new drawing or uh, new part and doing that one, instead of that one, we can just copy paste that part and break link that one, and we can just modify however we want. Okay, sir, is this clear? Paste special. Anyone having doubts or confusions regarding this?
Hello.
Yes, sir. Tell me.
Excuse me, sir. I have installed the CATIA. Left side, the product information is there. No? That is not readable. How to increase its font size?
Increase fonts. This time,
Yes.
right?
Yes. This information is not readable.
You can just keep control and scroll up it. Keep control and scroll. Move and scroll.
Okay. Okay. Thank you, sir.
It came, sir?
Yes, sir. Thank you.
Yeah, okay. So this is how we are doing assemblies for different projects. So anything you want to know about assembly, sir? So these are the major comments we are using in industries. Save management, that is also very important while saving the data. And this is break link command, also very important. And one more thing we have, like generally we are facing in the industry is desk issues. Okay. Desk issue is nothing but I already saved some few parts inside this propagated folder, but someone deleted that part. When I reopen that whole product in CATIA, that time it search that folder and tell that, so this part is won't be there. So please check. So I will show you this one. And all parts we have here. So what I will do, I will delete these 3 brackets inside the folder. I save this product and I will close this one. Here, I will delete this riser here. And if I open the product, so if I open this product from propagated folder, you see, this is desk issues. So did you get my points regarding this desk issue? Sir, is it clear?
Repeat once again, sir.
Actually, why it asks for desk, is it clear, sir? The reason behind the desk issues. If the part is relocated or part is deleted inside the folder,
okay,
and then if you reopen that product in CATIA tree, it is asking desk. You see, this bracket 3, I shown 03 bracket, I deleted in the folder. So here it is asking desk. So this part is missing from the folder. It just give instruction as to check this part. Okay. So how to clear this one means, there is a 2 methods we can approach. We can just search that part and we can put that part inside the folder and then reopen, or else here we can go to file, desk, and here we have a desk, right click, find. Here I will give you this one. So this part is displaying now. Sir, is it clear? How to solve the desk issues? In CATIA, majorly in big assemblies, we are facing such issues. Why? Because someone delete the part or someone relocate the part from the folder, then it will ask for a desk. And how to solve means, just go to the file, desk, and select that part, right click, and then find. And then select that part from the folder. So it will automatically take desk.
That means it is not permanently deleted.
Sir?
The parts is not permanently deleted. It will store somewhere else.
Yes, sir. If relocated or if you delete it from the folder also, it will ask desk.
Yes, yes,
If
sir.
we deleted or if we lost the data means again we have to recreate, or in the tree we have to delete that part
Okay.
and we can insert the new one.
Yes, yes, sir.
Yes, sir. Is there any doubts, sir, regarding this assembly commands? And if you have any doubts, you can just feel free to ask us actually. So I will try to solve. And
Dear
here also,
participant,
yes, sir.
dear participants, any doubt about assembly? Please, any queries? Get it clarified. Okay, proceed, sir.
Okay, and even sketch and part, we have a assembly mirror option here. Okay, symmetry, and here we have split command. This is like an some assembly levels we are doing this operations. So generally, I will copy this one and I will paste it here. So and I will create one plane here. So if I want to mirror this product, so select this one symmetry and select this component. And here just select the plane. So here the same subassembly is symmetry to the opposite level. Symmetry in the sense there is exact mirror to this one. And inside these parts, we check part level, it will shows only bodies. So this is how we can do mirror in the assembly level. And if I change anything in this subassembly level, automatically it will reflect into this one. Suppose symmetry 10 we have. This block. If I'm changing here, just I will cut this part by using split command. Okay, and I will save this one. You just check this one. That part color is showing red because it needs some attention. You see, it is asking for update. Why? Because that master part is updated. So this is also asked for updated. You just come inside the part, and if you give update, you see automatically here also it will update. Sir, is it clear regarding mirror and the components? How they are updating, how they are linking?
Yes, sir.
And here also we have a commands like translation. So this is part workbench only. And here also we have commands like annotations. If I want to represent any part in the 3D, you can just check with this annotation. Okay. Majorly in product development sectors, we are giving such information inside the parts, like what is the part name, what is that SAP number, and the details where it's going to assemble or which project. Such details they are filling with the help of this annotation, text with leader. So this is all about assembly workbench. So these are the major commands where daily we are using in our industries. Sir, any doubts you have regarding this workbench, assembly workbench, or any commands you are struggling? If you have any queries or doubts, just please ask. Okay. And we have one more command here. So I want this all assemblies as in one single part. Like I'm generating a one single CAD part from this assembly. To get that one, select the assembly. Here we have an option called generate CAD part from product. So if you select this one, it is asked whether merge all bodies of each part in one body. Okay, or else which are the bodies already is there, it is just convert into that bodies and you can keep it in one single part. So if I do like this, you see this is the one single part now. Okay. So now acts like a single part. To select anything, it shows like a bodies only here. Okay. This is all about. This is like an data exporting format. And few more data exporting formats are. If you go to save as, here you will find different structures here. Like step file format, actually we can open in almost all the modeling softwares. And it need license actually for step conversion. And for layer section is fine. Okay, and IGS, if I convert it to IGS, it came with some surfaces only. So if I open this one, unit clamp IGS, so in IGS format, we are getting a surfaces here. In step conversion, we are getting part bodies, but here we are getting surfaces. You can just see this one. I can hide this surface. You see, this is the IGS format. It will give the product in the surface. Gives the product in the surface. And again, we have one few more format like CGR. It is also like the IGS format. It's CGR we have. Okay, and the one disadvantage of this format, you can't drag this. You can't drag directly on this product. Okay, you should put a component or a part, and then you can go to product, the components, existing components, and then only you can able to open CGR. Okay, sir, is it clear about the exporting formats? That is clear, right? About exporting formats, IGS and CGR format.
Yes, sir.
If you have any doubts regarding CGR and IGS, you can just tell me. I will explain you once more. And if I want to export one more format is there. Here in CATIA, we can take it like 3D XML format. So these all are like exporting formats. And one more thing about the CATIA, lower ocean models we can open in higher ocean, and higher ocean models we cannot open in lower oceans. So while we are working with the different oceans, we should have aware of that, which ocean we have to work. And this 3D XML file, the one good thing about this format is we can open in any higher or lower oceans. Irrespective of ocean, it will open in CATIA. About this 3D XML format. It is just a representing format, and here you will not get any like tree structure like cat parts. If you check here, you will get how they model done. Okay, this part body and everything. But in these exported formats, you won't get any such informations. Even in all cat part or IGS or 3D XML, those are just a representation. It won't give the information about how they followed or how they did. Nothing it will give. It will give only the representation. Sir, is it clear?
Yes, sir. Yes, sir.
Just let me know, sir, if we are struggling or anything you have confused with the commands.
Guru sir.
Sir, tell me.
Some of the participants are requesting to share the assembly drawing videos. If you have any case studies other than this, can we share the same thing to participants?
I will check, sir. I will check and I will.
Yes, yes.
Send
The
you,
similar way, because any types of assembly, it will be the same.
Okay.
It will be easier to practice. If
Yes,
you have
sir,
such
sir.
kind of
Okay.
guidelines.
Okay, sir. Okay.
Okay. Participants, any queries regarding assembly? Please ask any doubts. Ranjit? Ranjit?
Sir, Ranjit is not there, sir.
Okay, no problem.
Shall we end the session, sir?
Yes. Just you can announce.
I'm here, sir.
Can we end the session, sir?
Okay, sir.
Okay, sir. Participants, tomorrow's session again, it will start at 9:30. So we'll share the joining link. It's the joining link is same as today. So you can join us tomorrow for the session. Thank you.
Okay, sir. Thank you, sir.
Thank you.
Sir,
Thank you.
feedback link.
Sir, feedback link is posted in the chat box, sir.